on a time crunch today. So, all right. So here is all of the work from the initial check your understanding for the significance test for P. So the first thing you want to do is you want to state the appropriate hypotheses. And in this case, the null or HO would be that P is 90%. And the alternative hypothesis would be that P is less than 90%. Let's see, because it asks us here if these data provide convincing evidence that less than 90%. So that's where the less than came from. And then notice that I clearly defined in words and listed what the parameter of interest is. It is P. And in words, that is the true proportion of students that can identify the smell of a skunk. In B, it's important that sometimes we understand that some evidence, kind of an intuition sort of evidence, is different than convincing statistical evidence. And so some evidence in support of the alternative hypothesis is simply that the sample proportion is consistent with the alternative. The sample proportion is 84%, which is clearly less than 90. So that's supportive of the alternative. That is some evidence, not convincing evidence at all, but it is some. And then in part C, it reminds you to check the conditions for performing a significance test. Number one, a random sample. Why is it important that we take a random sample? So what? Yep, so we can generalize to the population. If we can't do that, then there's no reason for us to even do any of this, because the entire question is trying to establish exactly what P is and isn't. Independence, the 10% condition. So what? Why do we do this? So we can sample without what? Replacement, right? Sample without replacement, and that doesn't mess up the independence. So we can sample without replacement. And then the large counts condition is so what? We can establish normality in the sampling distribution. So we can establish normality. Why do we even want to do that? So we can use all those handy dandy calculations like normal TDF, and we can use the normal distribution, things like table A, to calculate the probability of the observed value. Right? So in D, it asks you about that vocabulary word I said you needed to know. Calculate the standardized test statistic, which in this case is Z, and the p-value. So in this case, your specific formula is that. And then there's my work. And so the standardized test statistic is -2. Okay. From there, in order to calculate the p-value, I'm going to draw a sketch of the distribution. I'm going to label it. I'm going to place the z-score. Why am I finding area to the left and not the right? How do I know to do that?
Because it's less than 90%. We're
Yeah,
trying
in the
to prove
hypothesis.
this. Yeah.
Correct. We are seeking evidence for less than 90. So that's what tells me to go to the left. And so then my calculation of the p-value is here. All of my lovers of table A, feel free to continue using it. I'm not one of those. I hate table A. I prefer the calculator. So there's the calculation of my p-value. So this p-value, we will need to explicitly say that the p-value is 0.023. And then I finally, for the first time, writing for you, I've had several questions about this, what the full conclusion should be, and this is it. So it kind of combines the two things I had you interpreting yesterday into a single conclusion. So the first is the interpretation of the p-value, assuming HO is true, and then there's HO, p equals 0.90. There is an approximately 2.3% probability of getting a observed value, or p-hat, of 0.84 or less That's the more extreme, right? Purely by chance. And then the next is the second part, which is kind of your conclusion and your decision. Remember, we make a decision based on the value of P or the P value in relation to alpha, the significance level, to determine our decision. And our decision is whether we reject or fail to reject the null. Because our P value is less than alpha, we reject HO. You need to say that. Okay? That is your decision. And then your conclusion is that we do have convincing evidence of HA, which is less than 90% of students can identify the smell of a skunk. So now you see it all put together. And notice I haven't put anything about, where, like alpha anywhere in that conclusion, and you'll see today why that is. We're going to define alpha at the very beginning. Okay, so we don't have to do it there. It's okay just to put those two numbers after you define what they are. Notice earlier in my work, I clearly defined what this number is. So it's okay that it's just floating here because I told you what it was. Right? You'll see today that I will also tell you what alpha is up higher in the problem, so we don't have to